Hello, Cyber Explorers, and welcome to this episode of Tech Talk. I'm your host, Alan Wesley, inviting you to join me as we take a closer look at Kubernetes and some of its key vulnerabilities. Let me ask you something. Have you ever walked into a room and realized someone's already messed with everything before you got there? Feels off, right? Like things look normal on the surface, but something isn't adding up. That's exactly the kind of scenario we're dealing with when it comes to Kubernetes poisoning, a security threat that's quietly creeping into cloud environments. But before we get into the attack, let's talk about what Kubernetes actually is. Kubernetes is the engine behind cloud workloads. At its core, Kubernetes is an orchestration platform. It's what keeps modern cloud applications running smoothly. Think of it like an air traffic control system for applications running in containers. It decides which apps run where, how they scale, and how they communicate. And it's everywhere. According to the Cloud Native Computing Foundation, over 96% of organizations are either using or evaluating Kubernetes. The defense industrial base is no exception. Kubernetes powers everything from DevSecOps pipelines to AI-driven analytics platforms. But here's the problem. Just because it's everywhere doesn't mean it's secure. And that's where Kubernetes poisoning comes in. So, what exactly is Kubernetes poisoning? Kubernetes poisoning is when attackers inject malicious data, manipulate workloads, or exploit weak configurations inside a Kubernetes cluster. They're not breaking in the traditional way. They're tampering with how Kubernetes itself operates, making it work against you. Here's 5 ways they do it. 1. Poison container images. A supply chain attack where attackers slip malicious code into container images. Aqua Security's 2023 report found that 50% of public Kubernetes container images contain vulnerabilities. Once deployed, these poisoned images give attackers backdoor access. 2. Compromised API server. Kubernetes relies on its API server to manage workloads. If an attacker exploits weak role-based access control settings, they can manipulate workloads, delete services, or escalate privileges across the cluster. 3. Network traffic hijacking. Kubernetes manages how services communicate inside the cluster. Attackers can poison DNS settings, reroute traffic, or eavesdrop on sensitive data. In 2022, a Kubernetes-based AI model at a major financial institution was compromised when attackers inserted rogue routing rules, diverting transactions to an external server. 4. Malicious configuration injection. Attackers exploit Kubernetes misconfigurations by modifying Helm charts, config maps, or environment variables. This can disable security controls or allow unauthorized commands to execute. 5. Secret exfiltration. Kubernetes stores secrets, things like API keys, service account tokens, and database credentials. If improperly managed, attackers can steal them and gain full control over cloud environments. Why this matters for the defense industrial base. In the DIB, Kubernetes runs mission-critical applications, from AI-powered threat analysis to supply chain logistics. A poisoned Kubernetes cluster could mean AI models being manipulated with false intelligence, compromised software, pipelines, injecting vulnerabilities into defense contracts, attackers gaining control over military logistics, rerouting shipments or disrupting operations. And here's the troubling part. Many organizations don't even realize their Kubernetes clusters are vulnerable. How do we defend against Kubernetes poisoning? The first step? Treat Kubernetes security like a core part of your cyber defense strategy. That means enforce strong RBAC policies. Lock down API access so attackers can't manipulate workloads. Scan and verify containers. Never deploy unverified or untrusted images. Use trusted registries. Secure Kubernetes secrets. Store them in encrypted vaults instead of plain text inside clusters. Monitor and audit. Implement real-time anomaly detection to catch poisoned configurations before they spread. Limit AI to AI communication. Prevent uncontrolled cross-system data sharing inside Kubernetes environments. So the question is, how sure are you that your Kubernetes environment hasn't already been poisoned? Until next time, explorers, stay safe, stay secure, and always stay informed.